Alright, hello Algebra 2. So today we're looking at the second part of what we're doing with complex numbers. So Thursday we're looking at what are complex numbers, where are these imaginary numbers coming from. Today we're looking at doing some operations with them. So we're adding them, we're subtracting them, we're multiplying them, we're dividing them. So this got its own section just because if we added it to the other one that would have been like a 40-minute video and I didn't want to do that. You didn't want to do that. So it's its own separate section now. Now, the nice thing is if we're adding or subtracting complex numbers, then we're pretty much treating them like we would any other variable. So right now we're just going to treat that I as if it were an X or a Y or whatever other variable you like. So we're combining things that are like terms. So if we're looking for some like terms, we got a 4 here, we got a 7 here, neither of those has an I with it, so 4 plus 7 gives you 11. And then we're adding our imaginary numbers, so we have a 3i plus a 5i, that gets you an 8i. And the important thing to watch out for is that's it. Don't do anything with that. Don't combine that 11 and that 8 and call that a 19i or something, just like we wouldn't if that was an X or a Y or whatever other variable. If this one has a variable, that one doesn't, that's where it stays. So we got our real number, we got our imaginary number, we got our complex number, we just put them both together. So that's it. Pretty nice, huh? It's going to get harder. So if we're subtracting them, just watch out for, just like any other variable we're subtracting everything in the second set of parentheses. So this is a 12 minus that 8, which gets you a 4. And this is a 6i minus this I, and just like any other letter, if we don't have a number in front of there, it's a 1. So 6 minus 1 gets you 5. And it's a positive 5i because your positive 6 is bigger than your negative 1. And again, that's it. Don't do anything with that. That stays. Okay, one thing to watch out for with these is if we have some more negatives going on. So if we have a negative 9 minus an 8, that gets you a negative 17. And then we have a 4i minus and another negative 2i. So 4i minus a negative 2i gets you a positive 6i. So just watch out for those minus negatives going on. And again, that's it. Multiplying is where it gets a little bit trickier. Because if you think back to what we said about i's before, if we just have an I, that's an I. But if we have an I squared, that was a negative 1. So I'm just going to put that over here and put a little box around it. Because the big thing with these is just remembering to do something with that once we've got it. Because if we're multiplying, this is where we're going to end up with I squared. So if we have i's and we're adding them, we're subtracting them, we're not going to end up with an I squared. But if we're multiplying, now we will. So we're going to FOIL this. So first, 4 times 2 gives you 8. Outside, 4 times I gives you 4i. Inside, 3i times 2 gives you 6i. And last, 3i times I gives you a 3i squared. So that first part is exactly what we would do with it if it was any other variable. So that was an X or a Y or a T or whatever, we do that exact same thing. This is where it gets a little bit different. Because if we have an I squared, we said that's a negative 1. So I'm going to replace that I squared with a negative 1. And if we have a number next to a letter like that, that means we're multiplying. So this back here is really a 3 times a negative 1, which is really a negative 3. The rest of it's just going to drop on down here. And now we're combining our like terms, because now we have some more like terms to combine. So this right here, this is the big difference between i's and what we would do with any other kind of variable. So that's the reason this is a little bit different. So now when we're combining our like terms, we have this 8 minus this 3, which gets you a 5. And 4i plus 6i gets you 10i. And really the big thing there is remembering that that's a thing we need to do with it. So if we end up with an I squared, we need to turn that into a negative 1. So we can't just leave that as like an 8 plus a 10i plus a 3i squared like we would do if it was some other variable. You don't want to do this. So if we have an I squared, that needs to get turned back into a negative 1, because we want to make this as simple as we can. So we're going to end up with a real part, we're going to end up with an imaginary part, and we shouldn't have any other parts. So your things at the end should have at most two terms. So we should have a real part and an imaginary part. Cool. Let's try another one. So same sort of thing. We're foiling this. So 5 times 8 gets you 40. 5 times 2 gets you 10. That has an I with it. Negative 6 times an 8 gets you a negative 48. That's also got an I with it. And then we have a minus. 6 times 2 is 12. I times I is I squared. And again, we have an I squared, so we're going to turn that into a negative 1. So this is really a minus a 12 times a negative 1, which is going to give us a positive 12. The rest of it's going to stay. And now we're combining our like terms. So we have a 40 plus a 12 that gets you 52. And we have a 10i minus a 48i that gets you minus a 38i. So real part, imaginary part, we're done. Alright, now, usually you'll end up with both a real part and an imaginary part. Sometimes you won't. Sometimes you'll have something like this. So if we're starting off with something like this, we're going to start off by doing the same thing. So we're going to FOIL this. So 4 times 4 gets you 60. That's going to be a minus a 12i there. And plus this 12i here. And minus this 9i squared. Okay, same sort of thing as before. I squared is really a negative 1, so this is a minus 9 times a negative 1, which is going to get you a plus 9 there. And you got the 16 minus 12i plus a 12i. Ooh, what's going to happen to those 12 i's if we have one positive and one negative? Hopefully you said they're going to cancel each other out. So these are going to cancel. And we really just got 16 plus a 9. So sometimes you'll end up with something like that, where your imaginary numbers canceled each other out. And they did that because these things that we were starting out with back here are a thing called complex conjugates. Complex conjugates. I can spell conjugate. I can't spell conjugates. There we go. Complex conjugates. So that's what we call it when we have the same numbers with the same variables, but one of them is positive, one of them is a negative. So if we have one that's a plus, one that's a minus, but everything else is the same, it's going to end up doing something like this. Now, you might remember something similar when we were doing factoring. If we ended up with something like an x squared minus 9 that was coming from a positive and negative at the same number. So same sort of idea here. So those middle terms canceled each other out just like these middle terms. So same sort of idea going on there. Which is going to be useful when we're dividing. So if we're dividing, big thing here again is we want to end up with two things at the end. So we want a real part, we want an imaginary part. So we want to end up with a real number and then something times I. Not something divided by I. So we want to get that I off the bottom of our fraction there. And if it's just an I, the nicest way to get that off the bottom of our fraction is to say, I'm going to take the top and bottom of our fraction times an I. Because if you think back to things like reducing fractions or things like finding common denominators, we can take the top and bottom of our fraction times anything we want and we'll still have the same fraction. Like if I have 3/4 and I take both times 5, we'll have 15 over 20. That's the same as 3/4. Same idea here. So it just so happens that the thing we're taking at times this time is an imaginary number, but the same rules apply. So we're going to take this and we're going to distribute that I. So we get I times 4, which we're going to call 4i, plus a 5i squared. And on the bottom, we've got an I times an I, which is an I squared. Now, that doesn't immediately look any better. Why is that nicer? The reason that's nicer is because we said back on the last page that I squared is negative 1. So we're going to take both of these I squareds and we're going to turn them into negative 1s. So this is really a 4i plus a 5 times a negative 1 over a negative 1, which is much nicer because 5 times a negative 1 is just negative 5. So now I got this. Which I'm just going to rearrange into a 4 over a negative 1 times I minus a 5 over a negative 1, which is a negative 4I minus a negative gives you plus a 5. Oh, there we go. So once we're here, it's just a matter of making this look nice. It's getting from here to here, that's the main thing, and realizing, oh, we can turn those I squares into a negative 1. Everything after this is just rearranging to make it look nice, where we've got a real part and we've got an imaginary part. So getting here is the big thing. All right, let's try another one of those. So let's say we got this same sort of idea. If there's just an imaginary term on the bottom, we're going to take that times an I. So we're going to take all of this times an I. We're going to take this times an I. I'm going to put the I in. So we're going to distribute that. We've got a 4I plus an I squared on the top. We've got a 5I squared on the bottom. Now, eventually, the more we do of this, you might get to the point where you do some of these steps in your head, but I'm going to keep writing these out for now. So we're going to take these I squareds and we're going to turn them into negative 1. So we've got a 4I plus a negative 1 over a 5 times a negative 1. Okay, 5 times negative 1 is just negative 5. So we've really got 4I plus a negative 1 over a negative 5, which again, we're just going to make it look nice. So I'm going to call that a negative 4/5 I, and then minus and a negative will give you a plus that 1/5. So real part, imaginary part, getting here is the big thing. This is just making this look nice. Okay. Now, what if it's not just an imaginary number on the bottom? What if we got something like this? Now, this is where that complex conjugate thing is going to come in handy, because we said back here that if we have a positive and a negative of the same thing, those will end up giving us just a number there. So we're going to do that to the bottom over here. So instead of multiplying by an I, we're going to multiply by the complex conjugate of this, which is going to be a 4 minus a 2I. But if we do that to the bottom, we got to do that to the top. Which looks kind of ugly, but we're going to make it look nice. This is going to end up looking nice, trust me. So we're going to distribute this. 5I times 4 gets you 20I. 5I times 2I gets you 10I squared. And on the bottom, we're foiling that. So we got a 4 times a 4 gets you 16. Now, if you happen to remember that those middle terms are going to cancel each other out, you don't technically have to write them out. I'm going to write them out just for completeness. So we got a minus this 8I, and then plus this 8I, and then minus this 2I squared. Nope, that's 4I squared. I can multiply. That's a 4. 2 times 2 is 4. Okay, and now we're going to make that look nice. So these are going to cancel out. And while we're at it, we're going to turn all those I squareds into negative 1s. So up top there, we get 20I minus a 10 times a negative 1. Down here on the bottom, we've got a 16 minus 4 times a negative 1, which is about to look very nice, because up top, that's going to turn into a 20I plus 10, because your minus and negative will give you a plus, over 16 minus a negative 4 is going to give you a positive 20. That's it, positive 20. Cool. And then we're just going to take that and rewrite it as two different fractions. So I've got a 20 over a 20I plus a 10 over a 20. But 20 over 20 is just 1, so that's really just 1I. And then plus, you could either call that 1/2, and that would be fine, or if you call that 0.5, that would also be fine. Not thinking about the fraction decimal thing right now. Not at all the main point. So once we're here, we're good. So we got a real part, we got an imaginary part. Alright, let's try one more of these. So if our thing is already a minus something, then instead of turning our plus into a minus like we did back here, we turned a 4 plus 2i into a 4 minus 2i, we're going to turn our minus into a plus, and we're going to multiply by an 8 plus a 5i. But if we do that down here, we got to do that up here. Cool. Now we're going to FOIL both of those. So we're FOILing the top. 9 times 8 is 72. On the outside, we got 9 times 5, that gives you 45. That's got 9 with it. On the inside, 2 times 6 is 2 times 8 is 16. That's got 9 with it. 2 times 5 is 10. And that's an I squared. On the bottom, we've got 8 times 8 is 64. 8 times 5 is 40. That's got 9. That's going to be a minus 40i. And again, if you know that those are going to cancel each other out, you don't technically have to write them both out. I'm just going to keep doing that just so we know it's there. 5 times 5 is 25. And that's got an I squared with it. Alright. So these are going to cancel. Up top, we've got a 72. I'm going to leave that stuff for now. Plus this 45i. Plus this 16i. Plus this 10 times an I squared, which is really a negative 1. On the bottom, we've got a 64. These two cancel out. Minus this 25 times a negative 1. And then we're just making that look nice. So we're going to take those and we're going to combine some like terms up top. So 72 plus a negative 10 is going to give you 62. 45 and 16 gets you 61. That's got a 9. And 64 minus a negative 25 gets you a positive 89. And if you've got fractions that are not going to turn into nice fractions or even going to reduce nicely at all, I'm okay if you just leave it. Technically, you should probably do this. But, I mean, as far as which one looks simpler, in 6 of one, half dozen of the other, technically we want this because we've got a real part and imaginary part. You could make a case that sometimes this is what you would actually want to be working with. So either one of those would be okay. Getting here is the main point. Alright. So that is it for complex numbers, and I will see you next time.